Okay, we have here a pretty weird looking integral from the SwinBee 2019. This is problem 17. We have the integral from 0 to 1 over 6 of 1 plus 2x squared plus 3x squared plus 4x cubed on to infinity dx. Okay, now on one hand this is very simple because this is all a big polynomial, just power rule. But the troubling part here is that this goes on forever. So let's just go ahead and integrate this thing and see where it goes. So power rule on this integral of 1 is going to be x. Integral here, 2x squared over 2. The 2's cancel. The same thing is going to happen here. When we do this, we get x cubed over 3. The 3's are going to cancel. So what we're going to end up having is this is just going to be x to the 4th plus x to the 5th, on forever. And we're just going to need to evaluate this whole thing from 0 to 1 over 6. And of course, the 0, we don't have to worry about that. When we plug 0 into this, the whole thing becomes 0. So we just need to plug in 1 over 6. So when we do this, we're going to just get 1/6 plus 1/6 squared plus 1/6 cubed plus 1/6 to the 4th. And this is going to go on forever. But the nice thing about this is actually just a geometric series. We have a common ratio between each of the terms. We just need to figure out what that is. So like if I multiply from this first term to the second term, if I multiply by 1/6, we get 1 over 6 squared. If I do it again, multiplying by 1/6 here, we get 1 over 6 cubed. And so this is going to work. This is going to be our common ratio. We can call this our R value. And for the geometric series, we can just use our formula for this. We have our formula for an infinite geometric series, which is just A over 1 minus R. And then our A value is just going to be the first term. So we have our A. We know what our A value is right here, 1 over 6. We know what our R value is, 1 over 6. There's one condition on this. The absolute value of R needs to be less than 1, but that's no problem as we got 1/6 here. So this is going to be fine here. So let's just plug everything in. So our A value in the numerator, this is just going to be 1 over 6 here. Then in the denominator, we'll have 1 minus our R value, 1 over 6. This is going to reduce. We'll have 1 over 6. This is going to become 5 over 6. We cancel the 6's, and so for the final solution for this, we're just going to get 1 over 5. Okay, so there you have it. Not too bad. We just needed power rule and then the geometric series, and we're done. Thanks everyone for watching today. Have a good day.